In this video, we will talk about simplifying radicals and solving equations using the square root form. So let's start with simplifying radicals. As we talked before, square root of negative 75 has been impossible for so long for us, but now we learn something called I, which is an imaginary number. It stands for the negative that's under the radical. So the first thing we want to do is get rid of the negative by replacing it with an I outside the radical. So square root of negative 75 becomes I square root of 75. Now, to simplify square root of 75, you have two different options. First of all, you can ask yourself, what multiplies to give me 75? Can I think of a perfect square that multiplies to give me 75? I can think of 25 times 3 is equal to 75. Now, square root of 25 is a whole number, it's 5. Then I will know that the 5 will leave the radical because square root of 25 is just a 5. And then the 3 stays under the radical, so it's going to be 5i radical 3. This is one way to think about it. So basically try to divide 75 into two numbers where one of them is perfect square. Square root of 25 is a 5, it goes out of the radical. The 3, however, square root of 3 is not a whole number, so it stays under the radical. This is one way to do it. Another way is to create a factor tree. So, what multiplies to give me 75? If I cannot think of 5 or 3 and 25, I try to divide it into the simplest form. So 5 times 15 is equal to 75. 5 is a prime number, so I circle it. And the 15 can be multiplied or divided into 3 and 5. So 3 is a prime, I circle it. 5 is a prime, I circle it. So now, what multiplies to give me 75 are all these prime numbers, 5 times 3. Now, every time I have a pair of a number, this pair will leave the radical. So then I have a 5 outside the radical. The 3, though, is alone, so it stays inside the radical. So every time I have a pair of a number, the pair leaves the radical as one number. So I have a pair of 5, so 5 leaves the radical. 3 is alone, so it stays under the radical. This is a second way of doing it. Now let's move on to number 17. Since I have a negative under the radical, I start by replacing it with an I, square root of 49. Now the square root of 49 is a 7, because 7 times 7 is just 49, so my final answer will be 7i. Now let's move on to 18. Again, I have a negative under the radical, so the first thing I need to do is replace it with an I, square root of 18. Now let's think of 18. What multiplies to give me 18? 9 times 2. This is one way to think about it, okay? So I square root of 18 is I square root of 9 times 2, because 9 times 2 is 18. Now square root of 9 is a 3, so 3i. Square root of 2 is not a whole number, so it stays under the radical. So the final answer is 3i radical 2. So basically I divided 18 into two numbers where one of them is a perfect square that will leave the radical. Now, another way to think about it is to do the prime factorization. So take the 18 and let's do the tree. What multiplies to give me 18? I can think of 6 and 3. 3 is a prime number, so circle it. What multiplies to give me 6? I can think of 2 and 3, so circle it. So 18 is basically is equal to the multiplication of all these prime numbers, 3 times 3 times 2. Now, as you can see, I have a pair of the 3. So 3 leaves the radical, 2 is alone, so it stays inside the radical. So the answer is 3 radical 2. But don't forget the I, because we have a negative from the beginning under the radical. So let's put it between them, because it looks nicer there. And that would be my final answer. Let's move on to number 19. Square root of negative 25, since I have a negative under the radical, the first thing I need to do is replace it with an I. So I square root of 25. 25 is a perfect square, so square root of 25 is just a 5. I did not need to do any prime factorization for this one. It was simple and easy. 20. Let's look at 50. Again, since I have a negative under the radical, I can put an I to get rid of the negative, so it's I square root of 50. Now, can I think of two numbers that multiply to give me 50 where one of them is a perfect square? I can think of 25 times 2 is 50. Now, square root of 25 is a whole number. It's a 5. So I put 5i. However, the 2, square root of 2 is not a whole number, so it stays inside the radical. So this is one way to think about it. Another way to think about it is to do the factor tree. What multiplies to give me 50? 5 and 10. Circle the 5. It's a prime number. What multiplies to give me 10? 5 and 2. 5 is a prime number. 2 is a prime number. Then 50 multiplies to give me 5 times 5 times 2. I have a pair of a 5, so 5 will leave the radical. 2 is alone, so it stays inside the radical. Since I had an I from the beginning, a negative under the radical, don't forget to put the I in your answer. So the final answer is 5i radical 2. This is how you simplify radicals. Now let's move on to solving equations using radicals. Now in problems like this or equations like this, I will always have an x squared and a number in order to be using this method to solve. If I have an x in my answer, then probably I cannot use this method unless I do something else first. And this is what we're going to be learning in our next lesson. But for now, we're going to have an x squared and a whole number. Okay? So let's go ahead and try to solve this one. The first thing you need to do is to isolate the x squared. So I need to move the 25 to the other side. To do that, I need to subtract 25 from both sides. So I end up having x squared equals negative 25. Now I have to get x. Since I have x squared, to get x, I need to square root both sides. Now remember, when you square root x squared, the radical and the square cancel each other, so I end up with x. Since I'm square rooting, then the answer will be plus or minus square root of negative 25. Don't forget this step. Okay? So every time you square root, the answer will be plus or minus. Why? We're going to talk about this in a minute. Now let's see how we can solve this. Since I have a negative under the radical, I start by replacing the negative with an I. Now square root of 25 is a 5, since 25 is a perfect square. So my answer is going to be plus or minus 5i. This means that x can be either 5i or x can be equal negative 5i. So I have two different answers, and it does make sense. Why do I put plus and minus from the beginning? Because if I have plus 5 and I square it, I get 25. And if I have minus 5 and I square it, I get 25. So that's why every time I need to get a 25, which is this one, a 25, then I have to remember that my answer can either be plus or minus the 5. There you go, plus or minus. So every time I'm square rooting, I should always put a plus or minus, because my answer can either be plus, I'm squaring it, I get 25, or it can be a negative. I square it, I get also 25. Okay? So plus or minus 5. And the I, or the negative over here, is basically just the I. So I always have two different answers, as you can see. These two different answers gave me the same answer, which is 25. Okay? So don't forget the plus or minus. Now let's move on to number 22. The first thing I need to do, since I have an x squared and a whole number, is to isolate the x squared. So I'm going to keep the 2x squared and I'm going to move 32 to the other side. So I subtract 32 from both sides. I end up having 2x to the power 2 equals negative 32. Now I need x squared, not 2x squared. So I need to divide both sides by 2. So I end up having just x squared. Negative 32 divided by 2 is negative 16. Okay? I don't need x squared, I need an x. So I have to square root both sides. And remember, if you square root x squared, you get an x. And remember, the answer is going to be plus or minus square root of negative 16. Since I have a negative under the radical, I replace it with an I. And square root of 16 is just a whole number. It's 4. Then x in this case can be either plus 4i or negative 4i. Two different correct answers. Try it. If you square 4, you get 16. And if you square negative 4, you also get 16. So both of them are correct. The negative inside the radical is shown by the I. Now let's move on to number 23. Again, I need to isolate the x squared, so I need to add a to both sides. 3x to the power 2 is equal to 20. Now I need to get x squared by itself, so I need to divide both sides by 3. So x squared equals 20 divided by 3. I cannot simplify that. 20 and 3 do not go into each other, so I'm going to just keep it as it is. Now remember, I need an x, so I need to square root both sides. Don't forget plus or minus. So x in this case is equal to plus or minus square root of 20 over 3. Now, do I have a negative under the radical? No. So I do not need an I. We only have an I when we have a negative under the radical. So I don't want you to get used to every time you are adding or trying to find x squared or square rooting to put an I right away in your answer. Only if we have a negative under the radical, this is when we have an I in our answer. Since here we do not have a negative under the radical, then we do not have an I, okay? So the final answer is x equals plus or minus square root of 20 over 3. Now let's think twice about this. Can we actually simplify 20? Remember, we learned how to simplify radicals. Now I know I cannot simplify 3 because square root of 3 is just square root of 3 because square root of 3 is not a whole number. So I can divide this radical. I can put square root of 20 over square root of 3. Okay? So if you have a big radical, you can divide it into two small radicals, square root of 20 and square root of 3. Now again, I cannot simplify this because square root of 3 is just cannot be simplified. 3 is already a prime number. Now let's think of 20. What multiplies to give me 20? 2 times 10, okay, but they are not perfect squares. What else? 5 times 4, yes, 5 times 4 is equal to 20. Now I'm going to keep square root of 3 on the bottom. Now square root of 4, how much is that? Since it's a perfect square, I know that square root of 4 is equal to a whole number. So square root of 4 is just a 2, so plus or minus 2 square root of 5 over square root of 3. And that is going to be my final answer. So remember, if you can actually divide the radical to be able to simplify this, do that. Remember, 20 is 5 times 4. 5 is a prime number, so it stays inside the radical. 4, square root of 4 is a 2, since 4 is a perfect square, and that would be my most simplified answer. Now remember, if you cannot think of two numbers that multiply to give me 20, where one of them is a perfect square, you can actually do the prime factorization. So 2 times 10, and circle the 2. What multiplies to give me 10? It's 5 and 2. These are prime numbers, so circle them. So 20 ends up being equal to 2 times 2 times 5. Since I have a pair of the 2, so 2 leave the radical, and 5 stays inside the radical. And this is exactly what I got. So you have two methods, and you can use whatever method you like. Now I hope this video was helpful. Make sure that you do more practice.